Hello and good evening everyone. I welcome you all to India's largest e-learning platform, Unacademy. And I welcome you all to my session of EM Wave Propagation. And I welcome you all to our channel of GATE Conqueror. We are into EM Wave Propagation. And today's topic is on wave polarization. We completed the theory related to wave polarization. We'll do some wonderful numerics on wave polarization today. And this is the 14th class of this particular series. Welcome everyone. Before we start the class, let me introduce myself. I am Chaitanya Reddy. Just confirm the video and audio once before we move in. Just confirm the video and audio once. Sorry. Just trying to check the audio here. Yeah, it seems to be good. I have overall 15 years of experience teaching, guiding and mentoring GATE and ESE aspirants. Work as motivational speaker, pan-India for the past 12 years, expert in field theory and communications. It's the official Telegram link for GATE Conqueror channel. This is the link here. Try to take a screenshot of this. You can join us on Telegram to get a personal level assistance from all the faculties of our channel. Thank you, Karna. Unacademy provides two paid platforms. Plus subscription, other is iconic subscription. In Plus subscription, you got to have FaceTime of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access. You can join any number of courses within the time span. You can join rank improvement batches, unlike other platforms where they separately charge for rank improvement batches. We don't charge separately for rank improvement batches, and we don't charge anything for crash courses also. Everything is included in this Plus subscription. Similarly, in iconic subscription, you'll have all the features of this Plus subscription. You'll have all these features. Along with that, you have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts, preparatory study material, personalized test analysis, study booster sessions, and customized study planner. Go for Plus or iconic subscription. I recommend you to go for a no-cost EMI. No-cost EMI means total cost will be divided by number of months without any extra cost, which is student-friendly. Moreover, you can use our team code KNR10, which gives you extra 10% off and also complete team support. Iconic subscription, get 1:1 live mentoring increasing your chance of getting a top rank. The good news for GATE and ESE aspirants is now the study material, that is the best study material is available, curated by India's top educators. Comprehensive syllabus coverage will be there. Solved problems to build, or the solved examples will be given to improve your problem solving skills. Practice questions will be given chapter wise and also available for both plus and iconic. So do not wait. Take the subscription. Use the code KNR10 or team code to get extra 10% off and complete team support. These are the results here for GATE 2022. Top 10 rankers are mentioned here. You can see we got 3 All India rank 1s. This speaks volumes about the quality of education that we provide at Unacademy. Join us, join with the best faculty in India to crack the exam. And the good news is the price hike is extended to April 7th. So you can take the subscription up to April 7th with the previous prices. Notes are also available, so do not waste the time. Just use our team code KNR10 to avail extra 10% off and complete team support. If you are having any doubts, get in touch with our counselor. If you have any doubts in preparation journey, subscriptions or latest offers, you can dial this particular number and get in touch with our counselor to clear your doubts. This Unacademy Ask a Doubt feature, through which student can ask any number of doubts and get them clarified. Previously was available on app, now it is available on website also. You can ask 3 doubts at a time. You can get the solution in your preferred language. And also it is very easy to ask a doubt. Just click, crop and submit. Special class includes interactive live classes, polls for the learners, raise hand option. You never miss a class when the notification is on. You can download the lecture notes then and there. You can access any time and anywhere. Introducing community. You never miss any update from your favorite educator. It's sessions, notes and practice material. And also you can share your feedback directly with the educator via polls. These are the new batches. Every week we start 7 or 8 new batches. This is Resilience batch for GATE 2023. Started on March 30 for Electrical Explained Bilingual. This is Resilience batch for GATE 2023 for ECE Explained Bilingual. Started on March 30. Evolve batch for GATE 2023 will start on April 6th for Electrical Explained Bilingual. Evolve batch for GATE 2023 for Electrical Explained Bilingual start on April 6th. Ascend GATE 2024 for Electrical Explained Bilingual will start on April 6th. These are all the new batches here. You can join any of these batches using the code KNR10, which is our team code, which not only gives you extra 10% off, but also complete team support. This Ascend GATE 2024 for Electrical Explained Bilingual will also start on April 6th. We are into EMFT, EM Wave Propagation. Today we will discuss numericals related to wave polarization. It's a part of EMFT subject. EMFT. Subject has 5 modules. It has 5 modules. Module 1. Elements of EMF theory. Module 1 is elements of EMF theory. Common for both EC and electrical. For electrical it is complete syllabi, and for EC it is 1 module out of 5. We had already created a playlist on this. Wonderful playlist with videos and 50 hours of content. Is included in this playlist. For elements of EMF theory, the maximum content available on any channel is not more than 10 hours. Against that, you got 50 hours of content. The specialty of this is both GATE and ESE aspirants can utilize this particular playlist for their preparation, because not only the shortcuts, the formulas, the logics that we have covered, but also we have covered complete theory and all derivations, so that it will be useful for both GATE and ESE. In the previous year question papers of all GATE and ESE are also solved in this particular playlist. Module 2, this is the current module, which is on EM wave propagation. This is only for EC. Right now we have a playlist, 13 videos. Actually, this is the 14th one, and 26 hours of content. That is in this playlist. We are into this particular module, EM wave propagation. Today is part 14. Good afternoon, Bhaskar. How are you? After EM wave propagation is done, we will go for transmission lines, Bhaskar. Is that clear? This is what I was talking about, Bhaskar. Module 3. Transmission lines will start this weekend. Once EM wave propagation is done, we'll start transmission lines. One more very important module and very easy module. This we have module 4, waveguides. Module 4 is waveguides, which includes rectangular waveguides and circular waveguides. Circular waveguides are recently added. Module 5, Optical Fiber Communication and Antennas. Module 3 and Module 4 are not covered. We'll try to cover up. We'll start very soon. Optical Fiber Communication, I'll take a separate series. Antennas concept we had covered. In antennas, Mahamarathon series. This playlist has 18 videos, 38 hours of content. So total Module 1 we have 50 hours of content right away. Module 2, we need to finish some small portions of the Module 2. We have 26 hours of content. Module 3 and Module 4 not done. Module 5, part of Module 5 is done in Antennas Mahamarathon. We have 38 hours of content. We have 114 hours of content already available. I like to add 106 hours more. Making total of 220 hours of content for EMFT. Maximum YouTube content I had seen for EMFT is not more than 40 hours. 40 to 45 max. Against that we got 220 hours here again, which is almost like fivefold. Is that clear? In Module 1, which is elements of EMF theory, Module 1 is elements of EMF theory, which is common for both EC and electrical. And this particular playlist will be useful for both GATE and ESE aspirants. It contains 40 videos and 50 hours of content. Module 1 has 3 parts into it. First part is basics. Second is static field theory. And third is time varying field theory. Let us learn what we have studied in each of these modules. First section, basics, contains 3 parts. Elements of vector calculus, coordinate systems, Elements of vector calculus and coordinate systems. Discuss on elements of vector calculus. Elements of vector calculus basically includes understanding of terms like scalar, vector, unit vector, how vectors are added, that is vector addition, how they are multiplied, that is vector multiplication, basic laws of vectors, del operator and its properties, and vector identities. All this put together is elements of vector calculus. This was beautifully explained in that particular playlist. Yes, Ashish, please ask your doubt. Free what? YouTube content is free, no? Do we charge for YouTube, Ashish? Anything you need to ask, you can ask Ashish. Which content you are asking? YouTube content is free. Bhaskar, Karna, anything you need to ask? You are welcome to ask, dear. Okay? Fine. Playlist is available. Please go through Ashish Yadav. Please go through our GATE Conqueror channel playlist. There will be a playlist on elements of EMF theory with 40 videos, dear. And elements of vector calculus we discussed on quantities like scalar. What is a scalar, dear? A scalar is something which has only magnitude, no direction. Can you even tell me examples of scalars? Examples of scalars. Anyone? Examples of scalars. Mass. Okay. Examples. Mass. Distance. Time. All these are examples of scalars. Any electrical quantities which are scalars, dear? Any electrical quantities, Ashish, which are scalars? How about voltage? Voltage. Scalar or vector? Voltage is scalar or vector? Resistance, okay. Voltage, scalar or vector? Voltage is scalar or vector? Yes, dear, voltage, scalar. Current, current is current scalar. A scalar is something which has only magnitude, no direction. Is a current scalar. Vector. Ashish, current is scalar. Power, scalar. Current is not a vector, it's a scalar quantity. These are examples. Vectors. A vector is one which has both magnitude and direction. Examples: weight, displacement, velocity, acceleration, force, and torque. Examples. These are examples of vectors which has both magnitude and direction. Most of us think that yes, force, torque, magnetic moment, electric dipole moment, magnetic dipole moment, they all are vector quantities. Most of us think that current is a vector, which is not the case. But current is a scalar. What's the reason? A vector is one which has both magnitude and direction, and it obeys vector addition. As current does not obey vector addition, under the special case it is treated as scalar. Is it clear, Ashish? Wonderful. Wonderful, Bhaskar. Then we have seen unit vector. Unit vector always gives you the direction of vector. Then we have seen addition of vectors. Under addition of vectors, we have seen parallelogram law of addition and head to tail rule. Are also called as triangular law. It was addition of vectors. Then we had seen basic laws of vectors. The basic laws of vectors are commutative law, associative law, and distributive law of addition and multiplication. Addition and multiplication. So these are basic laws of vectors. Then we had seen multiplication of vectors. In multiplication of vectors, we had seen dot product, scalar product, and cross product or vector product. And we have also seen what are the basic laws of vectors that are followed by dot product and cross product. The laws like commutative, associative, distributive, which is also observed in this multiplication of vectors. Then we have seen the del operator, vector differential operator, a spatial derivative operator, and its principles. That is, what happens if del is directly operated over a scalar. Del directly operated over a scalar is called gradient. It results in a vector. Gradient of any scalar is vector. And we take the del value. Del dot gives you divergence, del cross gives you curl. Divergence of curl of any vector is 0. That is a vector entity. And when you do dot product between del and a given vector, it gives you divergence. And when you do the cross product between del and any other vector, it gives you curl or orientation. And also we have seen some vector identities. We have also seen vector identities which are divergence of curl of any vector is 0. Curl of gradient of any scalar is 0. That's A part. B part we went for coordinate system. Coordinate system. We'll see types of coordinate system. The types of coordinate system are Cartesian coordinate system, or rectangular coordinate system. Then we are seeing cylindrical coordinate system, also called as circular coordinate system. Third one is spherical coordinate system. The types of coordinate system. Then we have seen how to convert a point from one coordinate system to another coordinate system. Point transformation. Very important concept, how to convert a point from one coordinate system to another coordinate system. While I explain types of coordinate system, we give coordinates. For Cartesian coordinate system, it is x, y, z. For cylindrical coordinate system, it is rho, phi, z. For spherical coordinate system, it is r, theta, phi. And also we will define the range of each of these coordinates. In point transformation, we will convert a point from one coordinate system to another coordinate system. Third one is unit vector relations. Third one is unit vector relations, how these unit vectors are interrelated. How the unit vectors of the three coordinate systems are interrelated. Unit vector relations. Then we will see the expressions for dl, ds and dv. And also we understood how to write divergence, curl and gradient, and Laplacian. So we derived all this. Most importantly, dl, ds, dv, divergence, curl, gradient and Laplacian, all the three coordinate systems is wonderfully explained in that particular series. Clear? Those are basics there. Coming to the second part. Static field theory. This weekend we'll start here. Today we'll do problems on wave polarization. Static field theory is divided into electrostatics, study of static electric field theory, in which we had expressed or derived Coulomb's law and its applications. Applications include line charge, surface charge and volume charge. And Coulomb's law is a generalized law that governs electrostatics. And Gauss law, a special law that governs electrostatics, and its applications over point, line, surface and volume charges. Coulomb's law is a generalized law that governs electrostatics. Gauss law is a special law which can be applied only on Gaussian surfaces. The Gaussian surface is one which is symmetric with respect to charge distribution. Besides this, we have seen topics like electric potential, relation between E and V, these are some of the topics. Along with that, we also discussed about work done and energy density. In magnetostatics, we have seen the generalized law, which is Biot-Savart law and applications. A special law here is Ampere's law. And for an Ampere's law is a special law that governs magnetostatics, and for the Ampere's law to be defined, we need to have a finite conductor carrying a current I, which defines the magnitude of magnetic field around it. We are going to go for Ampere's law and applications. Along with that, we have seen scalar and vector magnetic potential. Scalar and vector magnetic potential. And failure of MMF. EMF refers to electric potential. MMF refers to magnetomotive force. Along with this, we are also done work done and energy density. We are also done with work done and energy density. That's in magnetostatics, and both in common. It's in topics like both in common. It's in topics like Poisson's and Laplace equations, we have seen Poisson's and Laplace equations and the general solution for the same. So wonderful problems we have done under Poisson's and Laplace equation like never before, which is a common topic. We have Poisson's and Laplace equation for electrostatic field and Poisson's and Laplace equation for magnetostatic field. And also we have seen boundary conditions. Boundary conditions are again dielectric boundary conditions and dielectric conductor boundary conditions. Dielectric boundary conditions are those where between two mediums there is a dielectric surface at the boundary, which is dielectric boundary condition. And we got the boundary conditions as the word statements as tangential component of electric field is continuous across the boundary of discontinuity. It is unconditionally continuous. ET1 is equal to ET2. Tangential component of electric field is continuous across the boundary of discontinuity. Now you may get this curiosity to ask why these boundary conditions are required. Boundary conditions are important for us because if you know the field on our side and you know the boundary condition there, you can predict the upcoming runs. Got it? So we can predict the upcoming data, the upcoming running program which determines the electric field. If the boundary conditions are dielectric boundary condition, the first condition is tangential component of electric field is continuous across the boundary of discontinuity. Next is dN1 is equal to dN2. If and only if rho s is 0, normal component of electric flux density is continuous across the boundary of discontinuity if and only if rho s is 0, where rho s is the charge that is deliberately placed on the boundary. It is conditionally continuous. The other ST1 is equal to ST2. Tangential component of magnetic field intensity is continuous across the boundary of discontinuity if and only if K is 0, where K is the surface current that is deliberately placed on the boundary. Similarly, we got Bn1 is equal to Bn2. Normal component of magnetic flux density is continuous across the boundary of discontinuity, which is unconditionally continuous. And if you take dielectric conductor boundary conditions, under dielectric conductor boundary conditions, as you know, the perfect conductor cannot carry any charge and thereby any field. Therefore, for dielectric conductor boundary condition, E tan is equal to 0. Tangential component of electric field on the surface of perfect conductor is equal to 0. D normal is equal to rho s. The normal component of electric flux density on the surface of a perfect conductor is equal to the surface charge density that is placed on the boundary. Here it is H tan is equal to K cross An, where K is the surface current that is deliberately placed on the boundary. Bn1 is equal to Bn2. Normal component of magnetic flux density is continuous across the boundary of discontinuity. This we are dealt, and as the process of deriving these concepts of electrostatics and magnetostatics, we derive Maxwell equations for static fields. Maxwell first equation: closed surface integral of d dot ds is equal to volume integral of rho v dv. Differential form del dot d is rho v. Source Gauss law for electrostatic fields. Second, closed loop integral of E dot dl is 0. Implies del cross E is 0. It is conservative field. Static electric field is conservative but not time varying electric field. This is from conservative property of electric field. Closed integral H dot dl is equal to surface integral of J dot ds. Implies del cross H is equal to J. This is Ampere's law. Fourth one, closed surface integral of B dot ds is equal to 0. Differential form del dot B is equal to 0. Clear? These are Maxwell equations for static fields. These are Maxwell equations for static fields. Then we are seeing time varying field theory. In time varying field theory, we have two major contributions. One is Faraday's law. Inconsistency of Ampere's law. If once you incorporate these two equations, you'll get Maxwell equations for time varying fields. First one, closed surface integral of d dot ds is equal to volume integral of rho v dv. Del dot d is rho v. Second one, closed loop integral of E dot dl is equal to surface integral of minus dou v by dou t dot ds. Del cross E is equal to minus dou v by dou t. Third one, closed loop integral of H dot dl is equal to surface integral of J plus JD dot ds. differential form. Del cross H is equal to J plus JD. J is sigma E conduction current density. JD is displacement current density, dou D by dou D. Last one. Closed surface integral of B dot ds is 0. Implies del dot B is equal to 0. These are Maxwell equations for time varying fields. Besides these topics, we also discussed about capacitors and inductors. Clear? That is what we do. In module 1, elements of EMF theory, we covered basics, we covered elements of vector calculus, we done multiplication of vectors, del and its properties, dot products, cross product, and vector entities. In coordinate system, we go for types of coordinate system, Cartesian, cylindrical, spherical. We do point transformation, how to transfer a point from one coordinate system to another coordinate system. We also go for unit vector relations, how unit vectors are interrelated. Then we go for the differential length, differential surface and differential volume. Then we went for divergence, curl, gradient and Laplacian. Clear? So these basics put together, (15 hours), static field theory, time varying field theory are revised along with capacitors and inductors. Module 2, is EM wave propagation. It is about to understand how waves propagate in a given medium. Okay. So this is the current module, module 2, EM wave propagation. We'll see what we have discussed under EM wave propagation. In free space. For free space, sigma is 0. For free space, sigma is 0. Epsilon r is 1. Mu r is 1. Here we got attenuation constant alpha, phase shift constant beta, velocity v, and intrinsic impedance eta. Okay. Fine. Is that clear? Yes, Bhaskar, as I told you, after wave propagation is done, we'll go for transmission lines. Okay, nothing to worry. Next is wave propagation. Wave propagation in materials, finite conductivity, sigma not equal to 0, epsilon r greater than 1, mu r greater than 1. Here we have derived generalized expressions for alpha and beta. We have seen velocity, and also we have derived loss tangent, dissipation factor given by tan phi sigma by omega epsilon, where phi is 2 times of theta n. Theta n is intrinsic angle of, we can say intrinsic angle or angle of intrinsic impedance. Third one, is wave propagation. In good conductors, for good conductors, sigma is far greater than omega epsilon. Sigma by omega epsilon is far greater than 1. Sigma by omega epsilon is greater than 100. Here we got the value of alpha, beta, velocity, penetration depth delta, and we differentiated penetration depth and skin depth. At lower frequencies it is called penetration depth, at high frequencies it is called skin depth. Alpha, beta, velocity, delta, surface resistance Rs. This is derived as 1 by sigma delta and eta. Fourth one, let's see, wave propagation. In good dielectrics, in the sense sigma is far less than omega epsilon. Sigma by omega epsilon is far less than 1. Sigma by omega epsilon is less than 1 by 100. Here we have derived expression for alpha, beta, velocity and eta. Then we have seen wave propagation. Wave propagation in perfect dielectrics, sigma 0, epsilon r greater than 1, mu r greater than 1. Here also we derive terms like alpha, beta, velocity and eta. Okay. Is that clear? Let us see a comparison of different quantities in different mediums. These 5 topics put together is nothing but wave propagation, different medium, Let us do a comparison of this. Anyone, any doubt, you can ask dear. Any doubts you can ask dear. Comparison. Let me start with free space. Free space. Followed by perfect dielectric, good dielectric, good conductor, and perfect conductor. So free space, perfect dielectric, good dielectric, good conductor and perfect conductor. We are discussing different types of quantities. Let us start with sigma, okay? Let us start with sigma dear. Okay, what is sigma value? What is sigma value? For free space, there is no conductivity. Sigma is 0. In perfect dielectrics, there is no conductivity, sigma is 0. Good dielectrics, small amount of dielectricity, small amount of conductivity will be there, sigma is very less. Good conductor, sigma is a large value. Perfect conductor, sigma is infinity. This is a journey of sigma from 0 to infinity. It is moving from free space to perfect conductor. In this way, if you are trying to analyze the important parameters in different mediums, you will get more understanding about how wave propagates in different mediums. This table will be very, very important for you. Next is alpha. Attenuation alpha is 0. In free space, perfect dielectric, no attenuation, 0. Here small amount of attenuation will be there, which depends on sigma. Sigma by 2 into under root of mu by epsilon. Here huge amount of attenuation will be there, given by under root of omega mu sigma by 2. Sigma is infinity in perfect conductor. Alpha is also infinity. Infinite attenuation, therefore wave cannot propagate in perfect conductor because it exhibits infinite conductivity. Next is beta. Beta is omega into under root of mu naught epsilon naught. In free space, mu is mu naught, epsilon is epsilon naught. Perfect dielectric, mu r is greater than 1, epsilon r is greater than 1. So mu naught is replaced by mu, epsilon naught is replaced by epsilon. Mu r is greater than 1, epsilon r is greater than 1. So what is happening to beta? Is it increasing or decreasing? Good evening. Yes, good evening, Prakash. What is happening to beta? It is increasing. What is the value? Omega into under root of mu epsilon. This fellow will hold the least value. Then for good dielectric, beta is omega into under root mu epsilon 1 plus sigma square by 8 omega square epsilon square. Definitely beta is omega into under root mu epsilon plus omega into under root mu epsilon into sigma square by 8 omega square epsilon square. Very clearly beta value is increasing. It's very clearly the beta value is increasing here. So slowly the beta is getting increased now. Okay. And good conductor alpha is beta. The beta is also equal to under root of omega mu sigma by 2. Sigma is a large value, therefore beta is still increasing. Perfect conductor, sigma is infinity, beta is infinity. The journey of beta, least value to highest value. Clear? Next, velocity 1 by under root of mu naught epsilon naught, which is C 3 into 10 power 8 meter per second. Velocity of light in free space. In perfect dielectric, 1 by under root mu epsilon. That is 1 by under root of mu naught epsilon naught into under root of mu r epsilon r. Mu r is greater than 1, epsilon r is greater than 1. Therefore, it is C by under root of mu r epsilon r, where mu r is greater than 1, epsilon r is greater than 1. Therefore, velocity is less than C. It is decreasing. It means at this point it will have highest. Then it has decreased in perfect dielectric. In good dielectric, velocity V is 1 by under root mu epsilon 1 minus sigma square by 8 omega square epsilon square. Still decreasing. It is still decreasing. Velocity is under root of 2 omega by mu sigma. Sigma is very large value, therefore V is still decreasing. Velocity in perfect conductor, conductivity is increasing to infinity here in perfect conductor, velocity is 0. Velocity is 0. Eta under root of mu naught by epsilon naught 120 pi 377 ohm intrinsic impedance of free space in perfect dielectric, eta under root of mu by epsilon, which is 120 pi into under root of mu r by epsilon r. Mu r is approximately equal to 1 for practical cases, epsilon r is greater than 1. Therefore, eta is decreasing. And both the cases you can see here, eta is a real value. If you go for good dielectric, eta is under root of mu by epsilon 1 plus j times of sigma by 2 omega epsilon. It is complex in nature. For good conductor, eta under root of omega mu by 2 sigma plus under root of omega mu by 2 sigma plus j times under root of omega mu by 2 sigma. Both these cases, it is complex value. Whenever there is a little conductivity present in the medium, it leads to reactance. The intrinsic impedance or the surface impedance will carry reactance value, therefore impedance will become imaginary in nature or complex in nature, having an imaginary term. For perfect conductor, as a wave cannot propagate, eta will become 0. Clear? This table is very, very important. Got it, everyone? This table is very, very important here. Any doubts? Any doubts you can ask. After EM wave propagation through different medium, and for pointing theorem will express power associated with any given wave. And we got a derivation. After deriving the derivation, complex pointing vector P is given by one by 2 E cross H conjugate. Similarly here complex power is given by 1 by 2 V into I conjugate. Similarly, instantaneous pointing vector given by P sinusoidal is equal to E sinusoidal cross H sinusoidal. Instantaneous power W sinusoidal is equal to V sinusoidal into I sinusoidal. Average pointing vector P average 1 by 2 real part of E cross H conjugate average or real power one by 2 real part of V into I conjugate reactive pointing vector one by 2 imaginary part of E cross H conjugate reactive or imaginary power 1 by 2 imaginary part of V into I conjugate. From this we can write average Poynting vector is 1 by 2 mod E mod H. We also know that the ratio of E to H gives you eta. If I write in terms of eta, then it is, if I write in terms of E, H is E by eta, therefore E square by 2 eta. If I write in terms of H, E is eta H, 1 by 2 eta H square. This gives you power density given in watt per meter square. And if you want to find power, W average, it is surface integral of P average dot ds. Expressed in watts. So that's about Poynting theorem data. Any doubts? Clear? That's about Poynting vector representing the power. Any doubts? Let us see one important point here. If you consider free space, in free space conductivity is 0. And if you consider perfect dielectric, here also conductivity is 0. Alpha attenuation is 0. Here also it is 0. Here intrinsic impedance, eta is eta naught, which is 120 pi, ratio of E to H. But here, it's under root of mu naught by epsilon naught. But here, eta is under root mu by epsilon mod E by mod H. This is 120 pi into under root of mu r by epsilon r, which will be less than eta naught. Now my genuine question is, here eta is decreasing. That means there must be change in ratios. There must be change in the values of E and H. So if there is a change in value of E and H, then there must be attenuation. So why the attenuation is 0 here? If attenuation is 0, E and H will not change. If E and H are not changing, eta will not change. But very clearly eta is decreasing. That means E and H are changing. If E and H are changing, attenuation is not 0 then. How can you justify that attenuation is 0? Please, anyone? How can we justify that attenuation is 0? Anyone? What you need to understand here is Attenuation is 0 does not mean that E and H won't vary. Attenuation is 0 implies power is constant. That means the product E into H is constant always. That's the meaning. If you understand the real meaning, that will be very easy for you. Now you see, eta is less than eta naught. Eta will be less than eta naught only when E decreases and H increases. So one thing is sure, E is decreasing, H is increasing, and the product E into H is always remaining constant. For example, here E is 8 and H is 1. Here E is decreasing 8 to 4, H is increasing 1 to 2. Here eta is 8, here eta is 2. Very clearly eta is decreasing, yes. Eta is decreasing, okay. E is decreasing, H is increasing, okay. But if you see the product, average power 1 by 2, mod E mod H. Here power is 4 watts. Here the P average 1 by 2, mod E mod H. Four into 2, that is 4 watts. The power is not changing. That means there is no attenuation. Attenuation does not depend on the values of E and H, but rather attenuation depends on the product of E and H. Is it clear? Any doubts? And today's topic is wave polarization. The polarization of the wave depends on orientation of electric field. Basing on the orientation of electric field, wave polarization divided into 3 types: linear, circular, and elliptical polarization. Linear polarization is the case where we have equal or unequal amplitude with same phase. Circular polarization implies equal amplitude out of phase by 90. Elliptical implies unequal amplitude out of phase by 90. So let us do the case study. But let me assume wave is propagating in z direction. What you are assuming? The wave is propagating in z direction. wave is propagating in z direction, electric field along x direction, magnetic field along y direction. And here, you assume that the wave is propagating in z direction with components of electric field, in both x and y. We have Ex and Ey. E has both components, Ex and Ey. Therefore, E is given as E naught x into e power j of omega t minus beta z ax, E naught y into e power j omega t minus beta z ay. This is of the form E is equal to Ex ax plus Ey ay. Removing the imaginary components, as in the case of matching, is given by E naught x cos of omega t minus beta z, E naught y cos of omega t minus beta z. This into x and this is into ay. If you consider that z is 0, at z is 0, this is Ex here, and this is Ey. At z is 0, what happens is, Ex is equal to E naught x cos of omega t minus beta z. Ey is E naught y cos of omega t minus beta z. If you consider z is 0, Ex is E naught x cos omega t Ey is E naught y cos omega t. Okay. Now let us do the case study for all the different kinds of polarization. Case 1. Linear polarization. Case 1 is linear polarization. In this subcase, equal amplitude and same phase. Equal amplitude and same phase. We are evaluating at z is equal to 0, and we got equal amplitude and same phase. This equal amplitude E naught x is equal to E naught y is equal to E naught. Ex is E naught cos omega t. Ey is E naught cos omega t. Doing this 2 by 1, Ey by Ex is equal to 1, implies Ey is Ex, y is equal to mx plus c. Here in the case slope m is 1 and c is 0. Under linear polarization only, some more subcase, unequal amplitude, and same phase. E naught x not equal to E naught y. From this Ex, E naught x cos omega t, E naught y cos omega t, 2 by 1, Ey by Ex is equal to 1. So that's the second case of linear polarization, unequal amplitude and same phase. Clear? Next is circular polarization. Next is circular polarization, which can get circular or near circular polarized waves. Equal amplitude, out of phase by 90. Do it here. This for circular polarization. Cos omega t, Ey, E naught, sin omega t. Out of phase by 90, therefore this is cos and this is sin. One square plus 2 square, Ex square plus Ey square is equal to E naught square. These are the form x square plus y square is equal to r square, equation of circle, representing that it is circular polarization. It is circular polarization. Here it is representing equation of a line, linear polarization. It is representing a circle, therefore circular polarization. Third one, elliptical polarization. Unequal amplitude, out of phase by 90. Unequal amplitude and out of phase by 90. Ex is E naught cos omega t, E naught x cos omega t, Ey is E naught y sin omega t, because unequal amplitude. This implies Ex by E naught x is cos omega t, Ey by E naught y is sin omega t. This is 1 and this is 2. 1 square plus 2 square Ex by E naught x whole square plus Ey by E naught y whole square is equal to 1. It's equation of ellipse. X by A whole square plus Y by B whole square is equal to 1, where A is the major axis and B is the minor axis. So it is representing ellipse. It is elliptical polarization. Let me consider any one of these topics and explain you about how polarization will work. Clear? Let me take a case of elliptical polarization and explain. Elliptical polarization Ex is E naught x cos omega t, Ey is E naught y sin omega t. Let us see how the ellipse is formed here. This for time t is 0. This t by 4. This t by 2. 3t by 4. T is capital T. Now you know omega represents the change of phase with respect to time. You know omega represents the change of phase with respect to time. Omega is 2 pi by t. Calculate omega t. When t is 0, it is 0. Cos 0, 1. Sin 0, 0. Ex is E naught x. Ex is E naught x. T is T by 4. Omega T is 2 pi by T into T by 4. It's pi by 2. It's pi by 2, cos 90 0, sin 91. Ey is E naught y. Ey is E naught y. Ey is E naught y. Next. T is T by 2 omega T. 2 pi by 2 into T by 2, that is pi cos 180 minus 1 sin 180 is 0. Ex is minus E naught x. Minus E naught x. T is 3t by 4 omega t 2t by 2 pi by t into 3t by 4 is 3 pi by 2 270. Cos of 270 0, sin of 270 minus 1. It's minus E naught y. Minus E naught y. Now if you see the orientation with respect to time, it's moving like this. Orientation is in this way. The ellipse orientation is in this way. Now you tell me, is it left or right? In the examination they'll ask, is it left or right? Is it left or right? How to understand? This is x-axis, this is y-axis, and towards me is z-axis, towards you is z-axis. Toward that z-axis, keep your thumb finger, any hand thumb finger. See whether the fingers are matching or not. In my case, it is matching. Which hand? It is right hand. Therefore, this is right elliptically polarized. If the orientation is like this, then left hand will match. It is left elliptically polarized. In that way, you must decide the polarization. In simple ways, anti-clockwise is right, and clockwise is left. The problem with this is, at times you will forget or you will get confusion. Anti-clockwise is right, it's okay, but if you are having any 1% confusion, whether it is correct or wrong, after some time, after you do not practice for some time, this confusion will arise. Then in the examination, if this thing is happening, you cannot attempt the question. That's why whatever exam you are writing, online, offline, or whatever it is, your hands are with you always. So just please check. Keep the thumb towards you and check. Anti-clockwise, right. Of course, need not check this. Clockwise, left. Got it? Now in this derivation, can anyone tell me how do you get this clockwise? We got anti-clock, right? How to get clockwise orientation? When I say 90-degree phase shift, Both are cos. When I say 90 degree, I change this cos to sine. Instead of this, if you make this sine and keep this cos itself, then it will spin the other way. If you make this sine and this cos, it will spin the other way. You will get left elliptically polarized. Got it, everyone? And when the ellipse is formed, the ratio of major axis to minor axis is given as axial ratio. Semi-major axis, this is semi-major, this is semi-minor. Of course, both the cases same answer you get, am I right? The ratio is same. Semi-major axis to semi-minor axis is called axial ratio. Elliptical polarization is the most generalized condition. In elliptical polarization, when you make minor axis 0, you get linear polarization. That means you are suppressing this minor axis so that you will have only one component, linear polarization. Therefore, minor axis is becoming 0, therefore axial ratio is infinity. And if minor axis is equal to major axis, if minor and major are same, then you get a circle, am I right? You get circular polarization. If minor is equal to major, axial ratio is 1. Therefore, for linear polarization, axial ratio is infinity. For circular, it is 1. For elliptical, it is between 1 and infinity. The general range of axial ratio for elliptical polarization is between 1 and infinity. 1, it is circular polarization. Infinity, linear polarization. In between, elliptical polarization. Yeah. Got it, everyone? That's the theory of wave polarization. We'll do some numericals related to wave polarization. Given Ex is equal to (16 e power minus j 100x a by 9 e power minus j 100x az is given. Tell me the polarization. Anyone, please tell me the polarization. Tell me the polarization. Anyone? Chandni? Bhaskar? Anyone? Unequal amplitude. First case, note down. Unequal amplitude. How is the phase? Same phase. Same phase means, remember, case 1, equal or unequal amplitude with same phase, linear polarization. Equal or unequal amplitude with same phase, linear polarization. Any doubt? Second, equal amplitude out of phase by 90. Circular polarization. Unequal amplitude out of phase by 90. Elliptical polarization. If it does not obey above 3 conditions, that is unpolarized. Waves said to be unpolarized. These 4 cases you must remember here. Unequal amplitude and same phase. Unequal amplitude and same phase. Same phase means linear polarization. Option A is the answer. This is concept oriented questions. In this concept oriented question, what happens is, if you know the concept, you will write the answer. Otherwise, there is no trial and error here, because this is purely on a concept. If you don't know that concept, you cannot attempt it. As simple as that. Unequal amplitude, same phase, linear polarization. Lot of discussion we have done in theory. We have done the case study. Now it will be very easy for you to do problems on wave polarization. Is that clear? Yes, what's the doubt? Yes, you can ask. You can ask. Try and solve this, dear. Anyone can tell the answer? Bhaskar, Prakash, anyone? What is the polarization? Given is (40 cos of omega d minus beta x) plus 45 degrees AX, 40 cos of omega d minus beta x minus 45 degrees AY. They are asking what is the polarization? Amplitudes equal phase varying from plus 45 to minus 45. Total phase difference is 90. Equal amplitude and out of phase by 90 is circular polarization. That's okay. But how can you tell me whether it is left or right now? The toss is between C and D. Good evening, Prashant. How can you tell, Prashant, whether it is left or right? कैसे बोल सकते कि लेफ्ट है या राइट है? सोच के बताओ. How can we tell that whether it is left or right? Anyone? Can you tell, Prashant? I'll tell you shortcut for this. Theta is 0. Theta is 90. Theta is minus 90. Take the first vector, the first component, plus 45. Somewhere around here. (45 degrees). Second minus 45, somewhere here. Somewhere here, minus 45. Now it is moving from first component to second component, plus 45 to minus 45. Now you tell me clockwise or anti-clock? Is it clockwise or anti-clock? Alango, good evening. See, electric field component is having equal amplitude and out of phase by 90, it is circular polarization. How to decide left or right? That is a shortcut I told you. Now it is moving in anti-clock direction very clearly. So what it is? It is left or right? Sai Vamshi, hide here. It is not moving clockwise, no. Plus 45 to minus 45. You see the curve, plus 45 to minus 45. How it is going? Clockwise or anti-clock? Anti-clock. You see the screen and move your hand. See how to identify. Listen everyone. How to identify, I'll tell you. Elango. Srikan. Good evening. How to identify, I'll tell you. Wait. See, this is X. This is Y. And towards you is Z. Towards you, you should keep your thumb finger. Please keep your thumb finger. Keep your thumb finger like this towards you. I am pointing my thumb finger towards me. You people point your thumb finger towards you. And see the fingers. How they are. Clock or anti-clock. Don't see my fingers, you keep your hand, take your right hand and keep the thumb towards you and see the fingers, how they are, clockwise or anti-clock. Yes, for right hand. Right hand clockwise or anti-clock? For right hand anti-clock. Very good. Anti-clock means right. Elango, will you check for left hand also? Not necessary. For right hand anti-clock means left hand clockwise. See here. Okay, check. If you want, you can check. For left hand, clockwise. Clockwise means left. Now in the diagram, it is moving from plus 45 to minus 45. From this point to this point. How it is moving? Clockwise or anti-clock? Anti-clock. Anti-clock means what? Right. Therefore it is right circularly polarized. Any doubts? RCP, right circularly polarized. Yes, let me know. Any doubts? Is the shortcut clear? Next one. Electric field of an EM wave propagating in the positive Z direction is given by E is equal to sine of omega t minus beta z dx sine of omega t minus beta z plus pi by 2 ay. Now you tell me the polarization, dear everyone. Just please tell me the polarization. Can you tell me the polarization? Anyone? See the amplitude 1. Here also 1. Equal amplitude. Equal amplitude. Here phase plus 0 plus pi by 2. Out of phase by 90. Equal amplitude and out of phase by 90. Polarization. Circular polarization. But sometimes he will ask you left or right also. Then how to identify left or right? Draw the shortcut method. Theta is 0. Theta is 90. Theta is minus 90. First vector, phase shift 0. Second one, phase shift plus 90. 0 to plus 90. Clockwise or anti-clock? Clockwise. Movement is clockwise, means left or right? Clockwise, very good, Elango. So left, circularly polarized. Of course, the options given are very weak here. Only one circular polarization is there, so by default you can write in this particular question. This is a previous year question. You can easily write, but if the options are difficult, then you need to probe more into this particular question. Very good, Elango. And how is your preparation going on? In couple of days we are starting transmission lines. On our channel we are starting transmission lines. As you know, we had completed elements of EMF theory. 50 hours we took for elements of EMF theory. And we are almost to the end of wave propagation, this series. And antennas also we had exclusively covered in antennas Baha Marathon series. And once this is done, 1, 2, 5 modules of EMFT will be done. 3 is transmission lines. It's nothing like that, Elango, your hard work. 3 is transmission lines. And 4 is waveguides. We'll start transmission lines and waveguides soon, okay? Solve this. E is equal to 0.5 AX e power j pi by 2 AY. E power j omega t minus j kz Tell me the polarization. Tell me the polarization. Anyone fast? Polarization. Elango, how to do this? E is 0.5 amplitude AX plus e power j pi by 2 AY into phase term. Can I write this as 0.5 is 0.5 into 1. E power j pi by 2 is e power j pi by 2 into 1. So here 1 can be written as 0.5 into 1 is e power j 0 into x plus 1 into e power j pi by 2 of AY. We need to rewrite this in this way. Now it is easy, am I right? Now everyone will answer. Now you answered here. Prashant, Elango, Vamshi, Srikant, anyone? Now it is easy, I'm right. Anyone? How is the amplitude? Unequal. Phase 90. Unequal amplitude out of phase by 90. Elliptical polarization. Left or right also I'll tell you. Answer is C. Because left or right is not asking. I'll tell you left or right also. Tell me. First time 0. Next time 90. Clockwise. It is left elliptically polarized. Yes, correct, Elango. Good, very good. Others also need to answer. Others also try to answer. Next question. If E is given by 10 times AY plus JAZ, e power minus J25x, is asking find frequency and polarization. Find out. Yes, Lalita, find out. Prashant, find out, dear. Anyone find out? How to find? This is the form e power minus j beta x. From the given question, beta is 25. Given it is propagating in free space, beta formula omega into under root of mu naught epsilon naught. 25 is equal to omega into under root of mu naught epsilon naught. We know C is 1 by under root of mu naught epsilon naught. Implies under root of mu naught epsilon naught is 1 by C into 1 by C. Omega is 25 into C. C is 3 into 10 power 8. 2 pi F is 75 into 10 power 8, or F is 7.5 into 10 power 9 by 2 pi. 7.5 by 2 pi is 1.2 into 10 power 9 giga. 1.2 gigahertz. Please note down. Answer can be A or C. The answer depends on polarization now. Find polarization. How we got frequency? Is that clear? How we got frequency? Is that clear? Yes. Everyone, how we got frequency? Is that clear? Everyone, please let me know. How to find polarization? Equal amplitude 10. How to write phase? 1 is e power j0, j is e power j pi by 2 is 10 into e power j0, that's 1, ay plus 10 into j is e power j pi by 2, cos pi by 2 plus j sin pi by 2, which is j. J can be written as e power j pi by 2 into az. Now it will be easy for you. Equal amplitude out of phase by 90. Circular polarization 0 to 90. Clockwise, that is left circularly polarized. (1.2 gigahertz) and left circularly polarized. Option A is the answer. Everyone, is that clear? Just let me know. Everyone kindly respond in the chat box so that I understand how you are following. Lalita Alango, Neha, Srikant, next. For this question, let us solve. Is 3 cos of omega t minus kz plus 30 ax minus 4 sin of omega t minus kz plus 45 ay millivolt per meter. Find polarization. Very important problem. Try to find out carefully. Yes, please find out. Any doubt in the process, you can ask. If you are having doubt in the process, you can ask dear. Any doubt in the process, please ask. Try to solve, please. Now, what is the thing here is, this is cos. Listen carefully. This is cos and this is sine. Clearly, they are out of phase by 90, no doubt in that. But the problem is, this is in not standard form. So I want to write in standard form. This is 3 cos of omega t minus kz plus 30 ax. You should have plus here, plus 4 times plus of something. So minus sin theta is cos of 90 plus theta. Second quadrant, cos is negative. Minus sin theta. So I can write as cos of omega t minus kz 90 plus 45 135. Now I written this in standard form. Remember, already 90-degree phase shift is proven. Why I am doing this is only to determine left or right. How to determine left or right now? This is 0 degrees. This is 90. First one is around 30. First point is around 30 degrees. Next is at 135. 30 to 135. Clockwise means left. Already we know that 90-degree phase shift is there. Amplitudes are unequal. Amplitudes are unequal. 3 and here and 4 here. 3 here, 4 here. Unequal amplitude, very clear. Out of phase by 90, very clear. Elliptical polarization is done. Only I want to know whether it is left or right. 30 to 135. Clockwise, left. Therefore, left elliptically polarized. Any doubts, please ask me. Left elliptically polarized, very, very important question. There are two very important models in wave polarization. This is one of it. Any doubt? You can ask here. Yes. Any doubt you can ask. Next. E is given by ax plus j 4ay e power j 2 pi into 10 power 70 minus 0.2 z. Tell me the polarization. This can be written as 1 into ax, or can be written as 1 into 1 is e power j0, 1 into e power j0 into ax plus 4 into j is e power j pi by 2 of ay. Now, if you write in this way, it will be easy for you. Next is the phase component. Clear? If you see here, amplitude unequal amplitude, out of phase by 90, very clearly elliptical polarization, phase shift 0 to 90, clockwise, left elliptically polarized, left elliptically polarized. Everyone, is that clear? Everyone, is that clear? Next, a right circularly polarized wave. A right circularly polarized wave is incident on a plane. Perfect conductor. Is incident normally. A right circularly polarized wave is incident normally on a perfect conductor. Perfect conductor will not absorb any energy. Then the reflected wave will be. Once it falls on this, the accumulation of charge constant will happen and the wave will be radiated back, and this surface will act as an antenna. The wave will radiate back with the reverse of orientation. So when right circularly polarized wave is incident, reflected wave is left circularly polarized wave. Reflected is left circularly polarized wave. And this fellow is not consuming anything. If the right circularly polarized wave is incident, the reflected wave is left circularly polarized wave. And remember, it is left circular polarized not because the reverse of direction, but this is because of the generation of the wave again, or this acting as an antenna. So many people think that right became left because of change in direction. Polarization will not get reversed by change in direction. For example, you are running in this direction by holding a fan that is rotating clockwise, indicating left circularly polarized. If you move like this, the fan will rotate in the same direction. The fan will not change its direction. It is always clockwise only. Because you are holding this and rotating, it is always clockwise only. So in the reverse of direction does not change polarization. But it is reflected from a perfect conductor. The reflected wave, this is acting as antenna that is generating. Most of the people will think that change in direction is responsible for change from right to left or left to right, which is wrong. Not students, even faculty will think the same. Many of the faculties also think that the change in polarization is because of the change in direction, which is an absurd, absolute false, completely wrong. Very big names, don't want to mention anyone, but unfortunate that people think that change in polarization is because of change in direction, which is not the case. I hope you understood. Is that clear? Next, let the electric field vector of a plane EM wave in a homogeneous medium is given by E is equal to Ex times of e power minus j of omega t minus beta z of Ax the propagation constant beta is a function of omega, and assume that beta of omega and Ex are known to us and they are all real. From information available, one of the following cannot be determined. Please tell me, very simple question. Very simple question. You know electric field. You know electric field. Can you determine polarization? Everyone, try to answer. Orientation of electric field determines polarization. Orientation of electric field decides polarization. Am I right? Orientation of electric field decides polarization. If you know electric field, can you determine polarization or not? If you know polarization, absolutely. If you know electric field, absolutely we can determine. If you know electric field, absolutely we can determine type of polarization. We can. Group velocity, we know beta, we know omega. Group velocity, Vg is d omega by d beta. You know omega, you know beta, you can find this. Phase velocity, omega by beta. You know omega, you know beta, you can find this. Power flux, or the power radiated. Pointing theorem 1 by 2. Eta h square. E square by 2 eta. Eta, where eta under root of mu by epsilon. Without the knowledge of mu and epsilon or both the fields E and H, you cannot determine eta, and thereby you cannot determine the power flux. This is what you cannot determine. The option D is the answer. Is that clear? Next question. Given electric field is E is equal to E naught of AX plus AY J times of 2AZ e power minus J omega d minus Kx plus Ky. X, Y, Z represent spatial coordinates, T represents time, omega and K are constants. The electric field does not represent a wave. It is changing with respect to space and time. It represents wave, no doubt. Represents a circularly polarized wave propagating normal to z-axis. Represents an elliptically polarized wave propagating in xy plane. Represents a linearly polarized wave. Please answer. Which of these options are correct? Please answer. Yes, everyone. Try to answer which of these are correct. It's a previous year question paper. It's a PYQ. Someone try to answer. It represents a wave. A is out of context. Tell me what is the answer between B, C and D. Between B, C and D, tell me the answer. Anyone? Between B, C and D, what is the answer? Try to take this as one pair, AX plus AY, J times 2AZ as one pair. J is there, 90-degree phase shift. Here amplitude is 2, and here what is the amplitude? AX plus AY. Vector A is AX plus AY. What is mod of A? Under root 2. Under root 2 is the amplitude here. Root 2 here is the amplitude here, and 2 is the amplitude. Unequal amplitude. Out of phase by 90. Unequal amplitude. Unequal amplitude. Why? Root 2 and 2. And out of phase by 90. Who is telling you out of phase by 90? J. Unequal amplitude out of phase by 90 is elliptical. Elliptical. So not linear, not circular. It must be C. But what this fellow is asking here is saying something. Represents an elliptically polarized wave propagating in XY plane. How can you determine whether it is moving in XY plane? Exactly, precisely, this fellow will tell you. Minus Kx plus Ky, XY, moving in XY plane. Got it? So option C is the answer. Option C is the answer. Now, is that clear? Everyone, is that clear? Next, this model is very, very important. Let us see how it works. Electric field of a uniform plane wave traveling along negative z direction, e power j kz, you can see here, minus j kz means positive z direction, e power j kz, negative z direction is given by the electric field of the wave is given by E is equal to Ax plus Jy, E naught into e power j kz. The wave is incident upon a receiving antenna. Remember, the wave is traveling in negative z direction. It is incident on a receiving antenna placed at the origin, whose radiated electric field towards the incident wave. It is reversing. It is radiating reverse direction, means what? Positive z direction. Remember, incident wave is along negative z direction. It is that wave is incident on the antenna, and the antenna is radiating in the reverse direction, positive z direction. It is radiating EA, AX plus 2AY, amplitude EI, 1 by R, e power minus j kz. Now, the polarization of incident wave. Just see this and tell me polarization. The polarization of the incident wave, the polarization of the antenna. See this and tell me the polarization. And if they are not equal, if they don't have same polarization, there will be losses. Losses due to polarization mismatch is how much? Which is called as polarization loss factor. If there is no sync in polarization, there will be loss. That will be calculated by polarization loss factor. Calculate and tell me. First, see the question and tell me what is the polarization. Polarization of the wave, polarization of the antenna, and if there is a mismatch, there is polarization loss factor. We need to calculate. Find out and tell me. Okay, tell me what is the polarization of the wave. Tell me what is the polarization of the wave. What is the polarization of the wave? See here, equal amplitude 1 and 1, out of phase by 90, circular polarization 0 to 90, left 0 to 90, clockwise, left circularly polarized. From polarization concept, wave is left circularly polarized, means clockwise, not linear, circular but clockwise, circular anti-clock, wrong. Answer must be between these two. Antenna, same phase, unequal amplitude. Here amplitude is 1, here amplitude is 2, but same phase. Unequal amplitude, same phase. Same phase means linear polarization. Of course, in B and C, both you have linear. Now the typical thing is to find whether it is minus 5 dB loss or minus 3 dB loss. Remember, the wave is circularly polarized. Antenna is linearly polarized. There is a polarization mismatch. Because of this polarization mismatch, there will be some loss that can be calculated by finding polarization loss factor. How much is the loss, I am asking? Anyone? Yeah. Good evening. GK antennas. What is the answer? Okay, can you tell me, dear? Wave is circularly polarized. If you are having any doubt in that, you can ask. Antenna is linearly polarized. There is a polarization mismatch. Due to polarization mismatch, there will be loss. How much is the loss? How do you understand? What is the answer? Whether it is B or C? Yeah, good evening, dear. GK antenna projects. Sorry, I don't remember your name, dear. The other day, yes, you used to attend my classes regularly, no? But I don't remember your name. I think you are running some institute also, I think, on projects. Can you tell me the answer, or shall I reveal the answer? Yes, wave, circularly polarized. Antenna, linearly polarized, either this or this half. This half or this half. That means the wave is like this. Antenna polarization is either this or this, linear. It can only receive this horizontal part or vertical part. How much percentage it can receive? 50%. How much is loss? 50% loss is there. 50% loss means how many dB down? Minus 3 dB. Option C is the answer. Shortcut. This is shortcut. If you want to know the procedure, then procedure is you should find polarization loss factor is determinant of or mod of unit normal of the wave dot product with unit normal of the antenna whole square. This is the formula for polarization loss factor. Wave AX plus JAY, magnitude root 2, dot product with antenna AX plus 2AY, magnitude root 5 whole square. This 1 by root 10 whole square, 1 by 10 of AX dot AX1, AX dot AY 0, AY dot X 0 plus 2J whole square, 1 plus J2 whole square, magnitude root 5 whole square, 5 by 10, 1 by 2. Polarization loss factor is 1 by 2. Then attenuation is complement of polarization loss factor. It is also 1 by 2. Means 50% attenuation. Attenuation in decibel. 10 log 1 by 2 to base 10. Minus 10 log 2 to base 10. Minus 3 dB. Please calculate. Once cross verify, calculate. Remember, alpha and PLF are complement to each other. Alpha and PNF are polarization loss factor are complement to each other. So 1 by 2, 50%, minus 3 dB is the answer. Is that clear, everyone? Is that clear? Similar kind of a question. Uniform plane wave, electric field of a uniform plane wave traveling in negative z direction. E of the wave, EW, is given by AX plus JAY E naught into E power j kz. This wave is incident upon a receiving antenna placed at origin and whose radiated electric field towards the incident wave is given by antenna 3AX plus J2AY E1 E power minus j kz. Again, is asking find the polarization of the wave, antenna, and the polarization loss factor and attenuation in decibel. Just calculate here. Similar question. First find polarization of the wave. EW AX plus JAY E naught into E power j kz. This can be written as 1 into E power j0 AX 1 into E power j pi by 2 AY E naught into E power j kz. Equal amplitude out of phase by 90. Circular polarization, to be more clear, left circularly polarized. left circularly polarized. Wave is left circularly polarized, no doubt in that. Antenna 3ax plus j2ay. 3ax plus j2ay. E1 e power minus j kz. Unequal amplitude. J is there out of phase by 90. Now it is elliptical polarization. Last time it was simple. Circular linear 50% minus 3 dB. Here shortcut won't work. Therefore we should find polarization loss factor. Determinant of unit vector of the wave dot product with unit vector of the antenna whole square. This is ax plus jy root 2 dot with antenna 3ax plus j2ay magnitude under root 9 plus 4 13 whole square. This 1 by root 26 whole square 1 by 26 ax dot 3ax, that is 3, x dot ay 0, ay dot x 0 plus j into j square minus 1 minus 2 whole square. Polarization loss factor is 1 by 26. Circular polarization, circular, not this. Next elliptical linear, not this. 1 by 26, 1 by 26. Last one you should find. Now polarization loss factor is 1 by 26. You got, alpha and PLF are complement to each other. So that is 25 by 26. Find alpha in decibel. 10 log 25 by 26 to base 10. Please find out and tell me. I am also calculating. Please calculate. This is 10 log 0.961 to base 10. Log 0.961 to base 10. This is minus 0.172. Minus 0.172 decibel we got. Check out. Minus 0.17 dB. Option A is the answer. Is that clear? One more problem. We'll end the class today. Today's class will end. Repeat the above problem. Electric field given as ax plus jay e naught e power j kz. Equal amplitude out of phase by 90. Circular polarization for the wave. Antenna. Equal amplitude out of phase by 90. Circular polarization. Both are circular. Polarization loss factor must be 0. We'll verify if you want. Polarization loss factor, that of unit vector of the wave dot product with unit vector of the antenna whole square. For the wave, ax plus jy by root 2. Antenna 2ax plus j2ay by root 8. Whole square 1 by 16 of ax plus ax dot 2ax, this is 2, 0, 0, minus 2 whole square, 0. Polarization loss factor is 0, as I told you. Why you are getting 0? Polarization loss factor will happen only when there is a change in polarization. Both are circular polarization. Polarization loss must be 0. Alpha must be complement of it, that is 1. Alpha in decibel, 10 log 1 to base 10, 0 dB. 0 dB. Circular, 0 and 0 dB. Circular, 0 and 0 dB. Option A is the answer. And this model is very, very important model, dear. This concludes wave polarization. Any doubts? Is that clear? Next, we will see reflection and refraction of plane waves in the next class. Thank you all, dear. Have a great day. We are trying to share some wonderful content here. Please share, subscribe if you are not subscribed, like the session, and please share among your friends so that most of them will receive this wonderful content. Thank you all.